Okay, everybody, thank you so much for your responses and for your messages and for attempting the problem. If you didn't know, this problem is a preview of what you can see during our 20-minute GMAT drill hosted by Lighthouse Prep. So if you haven't heard about it already, it starts tomorrow, Thursday, at 9 p.m. Indian Standard Time. So hopefully you can join us for that. Otherwise, here's a preview. I'm going to help solve the data sufficiency problem, which I had posted earlier. So the data sufficiency problem is asking us if triangle ADC in this diagram here is an equilateral triangle. And if you didn't know, an equilateral triangle is a triangle with all of the sides being equal and all of the interior angles being equal. So the question is triangle ADC an equilateral triangle? And statement 1, with data sufficiency, always start with statement 1 taken independently of statement 2 and see if you can solve it that way. So statement 1 says that angle ADC is a 60-degree angle, so I'm going to go ahead here and mark it on my diagram to say this is a 60-degree angle. Okay, also from the problem, you know that BAC is a 90-degree angle or a right angle. And just from a quick look, you can also tell that angle AFD is a 90-degree angle, so I'm going to mark that here. Okay, so from this, now I'm going to try to plug in as much information that I can reasonably or logically plug in using the triangle properties I know and the geometry that I know. So a few things that come to me immediately is that if angle A over here on the bottom left-hand side, A plus B equals 90 degrees, then right here, A plus B must also equal 90 degrees, so this must be equal to B. And then the other thing I know is over here, triangle AFD, the interior angles have to equal 180 degrees. So I've got 90 on the bottom right there, B on the bottom left, and B plus A equals 90. So over here I have A. And the same thing goes the other way around. The bottom left hand is a right angle, and the bottom right is B, so this must be A. Okay, now I can see that, let's see if I can change my color a little bit. Okay, I can see that this triangle right here is an isosceles triangle. I can tell that because the two bottom angles, A and A, are equal. Therefore, this must be equal and this must be equal. Same goes for the other side and the bottom, where the bottom, both the angles are B, so these two legs must be equal, and on the right-hand side, these two legs must be equal. Okay, so I have two intersecting lines that are bisecting each other, and the other thing I can tell from that is that the angles on the opposite side must be equal to each other. Okay, so I've got a lot of information out of this so far, but the question here still remains that is ADC equal to an equilateral, or is it an equilateral triangle? And this is about as much as I can solve. I guess I could solve one other thing, which is that these two things are equal, but no, the answer is no, this is not sufficient information. So statement 1 is insufficient. Now we're going to move on to statement 2. Statement 2 says, and remember, we're going to ignore what was written in statement 1, so I'm going to scratch this part out right here. Okay, statement 2 says that line EF is equal to line BC. So let's mark that on our little diagram. So this line right here, is equal to this line right here, or not equal to, sorry, is parallel to. And what that would do is it would make this angle equal to this angle because both the lines are parallel, so this equals B. Well, so what this does do for me is it gives me isosceles triangle, so I'm going to mark that here, right, because this and this must be equal because both the bottom angles are B, but it doesn't tell me whether this angle is equal to B. So I'm going to have to say that statement 2 is also insufficient. And now I'm going to try to combine both of them. So plug back in the 60 that I had before to see if that gives me enough information to determine whether or not this is an equilateral triangle. Well, the answer is yes, it does give me enough information, because if you look, if you have 60 degrees at the top and the isosceles triangle means that both of the bottom angles are going to be equivalent, then I know that the bottom two angles equal 120 combined, and 120 divided by 2 equals 60, so this must equal 60, and this must equal 60. So the answer is, with both statements combined, I can conclude that triangle ADC is an equilateral triangle. And there you have your answer. Hope you enjoyed that and are going to be able to attend for the 20-minute GMAT drill hosted tomorrow by Lighthouse Prep at 9 p.m. Indian Standard Time. And those of you who are in Texas like us, that's 9:30 a.m. Central Standard Time. Thank you very much, and I look forward to seeing you.